All right, so this is Siddig. I am here to show you some more math. It is really, really weird not talking to students, but I told you guys I would try to get a YouTube up, and I figured if I could do it before I left, then you could at least like check it out, and if you're just like missing me and you want to hear my voice, then you could watch this. If there are things that you want me to talk about or things that you want me to show you, I can do that. This video, I'm just going to start really basic. I'm going to do multiplying binomials, and I'm going to show the FOIL method right on myself. I'm going to show the FOIL method, and I'm going to show the box method. The box method is my preferred, but I'll show you both. And then as we move forward in time, whether any human being watches these or not, I will, I don't know what that was. I will take requests. So if there are things you want me to show you, things that I've already taught you that you want to relearn, things that you need to learn as you're moving forward, what else? All right, so I'm going to start with multiplying binomials. And I'm going to start with FOIL. And I know I have my back to you. I'm a teacher. That's just what I do in life. So I'm going to start with FOIL method. And I like FOIL method. When I was in school, FOIL method was what they taught you. You can also call it double distribution. As a teacher, though, I'm not that crazy about FOIL method because I feel like you end up, like you can only do a 2 by 2. And by 2 by 2, I mean a binomial and a binomial. Whereas the box method, you can do much larger things. So we'll start with FOIL. I'm just going to start really, really basic, like this. I will color code my FOIL. So the F in FOIL stands for first. So you multiply the first term times the first term. So there's your F. So then x to the first times x to the first, and there are little invisible ones in front. 1 times 1 is 1. X to the first times x to the first, those add. Hopefully you remember your power rules. And I get x squared. Okay, then the O in FOIL stands for outside or outer. And then the outer are the two that are furthest from each other. So I have x times -5. Remember, this is still a 1. So 1 times -5 is -5x. I'm going to run out of colors. The I stands for inner. So first, outer, inner. The inner is right here. That's 3 times 1x. 3 times 1 is just 3. So you get 3x. Notice we're going to have some like terms. And then we'll go ahead and do black for L for last. And that's the last 2 terms. 3 times -5 is -15. All right, now you're pretty much to your answer, except you need to combine any like terms. Like terms have the same last name. What I mean by that is this guy has an x squared as a last name, whereas this guy has an x to the first, and this guy has an x to the first. Therefore, they're like. This guy has no x, so he's not related, okay? They can all hang out in the same sentence, but these two will actually combine. So you take -5 plus 3. And try to write your signs correctly. If you are not good at adding and subtracting, you can use a calculator. I have no problems with that. In fact, I recommend it because you can still learn high school math even if your elementary and middle school math was not great. So your final answer here would be x squared minus 2x minus 15. Okay, I'm not going to take more time on FOIL because is how I feel about FOIL. All right, so it's not the best method, I think. I prefer box method. FOIL, the problem is you have to remember it, and here's the big problem with FOIL. If you take something larger than a 2 by 2, which, you know, I like to, that's what I'm into. I do first, outer, inner, last, and you will notice I completely ignored a term. Okay, so FOIL is a great method. It was great when I was in school, but it only ever works for a 2 by 2. So it does not work here, so I prefer the box method. I did not invent any of these methods. I just teach these methods. So if you hate it, don't write me an angry letter because I don't care. Box method is called the box method because you literally use a box to do your multiplication. Weirdly, I saw on Facebook, it's probably like Facebook, somebody posted like how people use the box in elementary school for like adding and subtracting stuff. I think adding and subtracting stuff, and maybe even multiplication, and how it applies then to high school. All right, so box method. I'm gonna take, well, I would totally take the same problem I just did, except I don't remember what it was. I think it was that. I think. All right, if I remember my answer. Now with the box method, it's kind of like a multiplication table. The reason it's a 2 by 2 box is you have 2 terms in this binomial and 2 in this, hence the binomial part. If you had something larger, you would just add more boxes, which is cool because if you add more boxes, you could go on forever. All right, we're gonna do x plus 3. It does not matter if you put the x plus 3 here or here. Does not matter. Okay? You just have to put one of them on the top and one of them down the side. Okay, I'm going to do 2 problems for the price of 1. So you can see that the order of x plus 3 here versus x plus 3 doesn't matter. All right, once again, x times x gives me x squared because it's 1x to the first. If you want to draw on your invisibles, go for it. 1x times 3 is 3x. Negative 5 times x. I'm sorry, I should slow that down. I'm assuming you've seen this already and it's just a recap, but maybe you haven't seen this already. All right, you multiply in parts. So if I want to get to the first box, I'm going to use the first row and the first column, these 2 pieces. Whereas if I'm at this box, I'm going to block this first row and the second column. All right, so here, this first box gets first row, first column. Now, to multiply here, I'm going to do that and that. So all I care about is this first row, second column. So 1 times 3 is 3x. Okay, for this one, I'm going to block the second row and the first column, and that will give me x times negative 5, which is negative 5x. And then, I'm going to block first row, first column, and get this last piece together. All right, so I wish I had big giant, I have big giant rulers, but I wish I had like big long straight ones. So the idea here is they're too wide, but you would block like that, and what you want is here and here. I guess that's on my wish list now, is rulers that are wide enough but not too wide. So negative 5 times 3 is negative 15. Now, if you remember the last problem, it's the same. I collect my like. The other nice thing about box method is most of the time your like is going to be on that diagonal. Negative 5 plus 3 is negative 2x minus 15. Okay? Here the same thing happens. So 1x times 1x is 1x squared. X times negative 5, because that's the location, is negative 5x. 3 times x, because that's the location, is plus 3x. How ridiculous do my arms look when I do that? And then 3 times negative 5, so marked there and there, I get negative 15. Notice it's almost the same, except my diagonal's flipped, but I'm still going to combine the like terms the same way and get the same answer. Okay? That was multiplying, done very, very quickly. All right? But like I said, first video, I'm not sure how I feel about this YouTube thing, but I want you guys to have it as an option if you need it. I know none of my classes right now are working on this specifically. This is a second semester Algebra 1 concept. Most students do pretty well with it. Where they run into trouble is factoring. That could be another video. I could show you guys Xbox if that's what you're into. Yeah, I don't know. I hope this sort of helped. We'll see. And we might end up re-recording the whole thing just because I went too fast like a crazy person. I don't know. All right.